everyone, let's understand this question. A person needs a lens of power minus 5.5 diopters for correcting his distant vision. For correcting his near vision, he needs a lens of power plus 1.5 diopter. What is the focal length of the lens required for correcting? Here two parts are given. In the first part we need to find distant vision and second part to find near vision. So let's write first the given data. So here power of lens is given as minus 5.5 diopters. This value is given for distant vision, right? And again the power of lens is given as plus 1.5 diopter. This value is for near side vision. So let's write this. Here we need to find the focal length, right? So the power of a lens is related to its focal length is given as power is equals to 1 divided by focal length. This is the formula which we are going to use. Here P is power which is measured in diopters, which is represented as D, and F is the focal length which measured in meters, represented by small m. These are the units. Now let's find out the two parts. For the part 1, we need to find for distant vision. So now using the above formula, which is P is equals to 1 upon F. Here this formula we can also write F is equals to 1 upon P, right? So now substituting the values, 1 divided by power. For distant vision the power is given as minus 5.5. So solving this we get minus 0.1818 meters. Here the unit is given as diopter. Focal length unit must be in meter. If we take only two values after the decimal, we can write minus 0.18 meter as the final answer. So this is the focal length for distant vision. Now for the second part, we need to find focal length for near vision, right? So again we use the focal length is equals to 1 divided by power. Now substitute the value for power, which is given as positive 1.5. Now solving this we get plus 0.6667. The unit must be in meter. Now taking 2 digit after decimal we get plus 0.67 meter. Here 6 is greater than 5, right? So we increase 1 in 6, right? So 6 will become 6 plus 1 will be 7 because 6 is greater than 5. So this is the value for focal length for near vision. Here I am using the signs which is negative and positive all the time. Why? It is very important to know whether the power and focal length of the lens are positive or negative, because it defines many things like type of lens, how it bends, slide, and how it corrects vision. So if for the positive sign, here the positive sign means the lens is convex or converging lens, and for negative sign it means the lens is concave lens or diverging lens. So sign convention is very important for these type of questions or numerical. So remember this. Thank you for watching. If you found this video helpful, please like, share and subscribe for upcoming videos.